Hi, and welcome to the bond valuation spreadsheet help file. So in the first spreadsheet called bond valuation workbook, we're looking to solve the bond valuation for these three examples. So there's a little hint here, use the PV function. So I'm going to go to formulas and call up, search for the PV function, and call this up. So rate is going to be our required rate of return. N per will be our number of years. This is an annual compounding problem. And payment will be our annual payment. The future value will be our par value is considered the future value because par value is the price of the bond when it's first created and when it's retired. So we consider par value our future value because that's what we're going to pay out to bondholders in the future. Okay, so let's hit OK to calculate this, and we see that the bond value is $1,000. Well, if the coupon rate is 10% and the required rate of return is 10%, they basically are nullifying each other. So the 10% you make versus the 10% it depreciates every year is going to nullify each other. So we would expect the bond value to be equal to future value if the coupon rate and the required rate of return are equal. But let's look what happens if the required rate of return is lowered, if we have a 9% required rate of return. So again, we'll use that present value function and we'll put in our rate, which is the required rate of return, our N per, which is the number of years, our payment, and then our future value. And we see that the bond value increases. And if we go down to 7%, our bond value increases even more. So the lower the rate of return, the required rate of return, the more valuable the bond is as far as the current bond value. And you can kind of think of it this way. If the bond is paying 10% and you require only 7%, that bond is more valuable than the bond that is paying 10% and you require 9%. So not as, this means the risks are higher. Okay, so these questions down here are just a second set of questions that you can answer now that you know how to answer them. Let's move on to the next problem, which is yield to maturity. So in yield to maturity, it's telling me to use the internal rate of return function. So let me just resize this. So let me go to, you can also go, if you have the pull down of financial functions, all these functions should be able to be found in financial functions as well. So all I have to do is highlight all the values from year 0 to year 10 and select OK. And this will calculate the yield to maturity rate. So this is basically saying if in year 1 I'm paying $1,080 to invest in this bond, here's all the interest I receive from years 1 through 9, and then finally in year 10 I get the principal $1,000 back and the $100 dividend for that year. This is my actual rate of return based on my investment. Okay. Now, what about if we're trying to calculate a bond's yield to maturity? So yield to maturity is an interest rate. So we're going to use the rate function to calculate this variable. So we'll type in rate, go and get the rate function. So our N per is the number of years to maturity, which here is 10 because it's an annual problem. The payment is going to be the interest payment. The present value is the current bond price, because current is present. That's the present value. And the future value is par value. So the actual bond's yield to maturity is 8.77%. And what's interesting is this 8.77% is the same as this number here because this is a $1,000 bond paying a 10% return as well. And you see how the current yield is the current value of the bond is 1080 and the future value is 1,000. And up here we had this is the current value of the bond, the present value, and the future value is 1,000 plus 100 dividend, and that's how they're just sort of, these are the same numbers basically, but we're calculating the yield to maturity using the rate function instead of internal rate of return. And that's the same problem. This is the same problem duplicated twice. So we have one. So let's look at a new type of problem. So here's one, valuation for a semi-annual bond, and here we're looking for the current bond price. Okay, so to calculate this, let's first put our variables in so we know what we're dealing with here. So our par value is our future value. Okay, this is our coupon rate, but what we're using for rate is our required rate of return. So this is actually the rate for the problem. Interest payments will be our payments, and our interest payments per year is 2. So this is our frequency, or M. Okay. Now our NPER, years to maturity, is not our NPER. NPER is going to be years to maturity times 2. So we're going to find the current bond price, which means what we're looking for here is present value. So that would be the formula we're going to use to calculate this present value. Okay, so we have our rate. This is our rate, but we're going to have to divide this by our frequency. And our NPER is going to be number of years multiplied by our frequency. Payment is 50. Remember, the annual payment would be 100, but the semi-annual payment is 50, and the future value is 1,000. So that would calculate to $885 would be the current value of the bond. Okay, so let's move on to the next workbook, the bond yield to maturity. So this is a spreadsheet exercise out of the chapter, and again, these are similar problems to what was used before. If we want to calculate yield to maturity, a yield to maturity is a rate. So we're going to use the rate function here. So just like before, now this is again a semi-annual interest problem. So if they give you the, so we have to look, we're solving for rate. So we just have to remember this is semi-annual problem. So NPER would be the number of years times the frequency, which is 2. So already here we have the number of periods per maturity, 30. So NPER has already been expressed as 30, so we don't have to multiply it. The payment here is the semi-annual interest payment is 30. The present value is the current price of the bond, and the future value is the par value. And this would help calculate the rate. So here the rate is 3.7%. And this is just now the second type of problem here is calculate the bond value. So calculating bond value is calculating present value like we saw before. So I'm going to use present value to calculate. In this case we have, if we're looking for the rate, we're going to use the yield to maturity as our rate. NPER is the number of periods to maturity, which is 30, which is at 15 times 2. Payment is our semi-annual interest payment, and our future value is our par value. And then this will calculate our current bond value. Okay, this actually looks too low, so I think I missed something. So let me just go back in. Yes, so the rate, this is the yield to maturity rate, which is an annual rate. I'm going to have to divide that by 2 to get the semi-annual rate. Okay, that looks better. Okay, so that's calculating the bond price. So very similar to what we did over here in our bond valuations, but more in a word type of problem, which I've laid out for you here. Okay, so that is the spreadsheet help for Chapter 6, Rates and Bond Value. Thank you, and I hope you found this helpful.